The latest observations of 3I-ATLAS have revealed something that's making astronomers question everything they thought they knew about comets. Just 2 weeks ago, the Hubble Space Telescope captured images showing this interstellar visitor doing something that shouldn't be physically possible. Instead of developing a tail that points away from the sun like every other comet in history, 3I-ATLAS is glowing in the opposite direction, extending a brilliant plume of light directly toward our star. The measurements are even more bizarre. This sunward glow stretches 10 times farther than it is wide, creating an anti-tail phenomenon that has never been observed before. When astronomers try to explain this through normal comet physics, they hit a wall. Solar radiation pressure should push material away from the sun, not toward it. Yet 3I-ATLAS is doing exactly the opposite. But that's just the beginning. During September's lunar eclipse, astrophotographers captured 3I-ATLAS suddenly turning bright green, a dramatic colour transformation that happened literally overnight. Here's the problem. Spectroscopic analysis shows this object contains almost no dicarbon molecules, the compounds that actually create green glows in comets. So what's making it green? Nobody knows. The James Webb Space Telescope's chemical analysis delivered results that broke every model of comet composition. 3I-ATLAS has an 8:1 ratio of carbon dioxide to water, making it the most CO2-rich comet ever observed and placing it 6 standard deviations beyond normal values. The Very Large Telescope detected pure nickel emissions streaming from the object, something that's impossible in nature because nickel and iron always occur together in cosmic processes. And then there's the age factor that changes everything. Trajectory analysis suggests 3I-ATLAS is over 7 billion years old, making it potentially older than our entire solar system. This ancient wanderer from the galaxy's thick disk has been travelling through space since before Earth existed, carrying within its structure materials and processes that predate everything we know about our cosmic neighbourhood. Tonight, we're diving deep into each of these impossible discoveries, exploring what they might mean for our understanding of objects that travel between the stars, and examining why some scientists are beginning to ask whether we're looking at natural phenomena or something far more extraordinary. Before we begin, don't forget to like, subscribe, and hit the new hype button, but only if you genuinely enjoy calm science to relax with or fall asleep to. And tell me where you're listening from and what time it is there. Some researchers have suggested that what we're witnessing might be explained by conventional comet behaviour under extreme conditions. Perhaps 3I-ATLAS contains unusual ice compositions that create different sublimation patterns. Maybe its trajectory through interstellar space has altered its internal structure in ways we don't yet understand. These are reasonable scientific hypotheses, attempts to fit this anomaly into our existing framework of knowledge. Yet the more data that emerges, the more the conventional explanations strain against the evidence. The sunward glow isn't just unusual, it's accompanied by a host of other anomalies that paint a picture of an object unlike anything we've encountered. The chemical composition is wrong, the behaviour patterns are wrong. Even the timing of its arrival seems to mock our understanding of random celestial mechanics. Eric Cato, the Harvard astronomer who co-authored the detailed analysis of this phenomenon, emphasized that the sunward extension wasn't a subtle effect requiring sophisticated instruments to detect. With proper viewing geometry, this would have been a spectacular, unmistakable feature visible to any telescope capable of resolving the object's structure. The fact that we're seeing it compressed to a factor of 2 difference suggests we're witnessing something truly extraordinary. The scientific community is divided on what this means. Conservative researchers argue that unusual comet behaviour, while rare, isn't impossible given the extreme conditions of interstellar space. 3I-ATLAS has potentially been wandering the galaxy for billions of years, exposed to cosmic radiation, gravitational perturbations, and thermal cycles that no solar system comet has ever experienced. Such extreme aging might produce sublimation patterns that create unexpected optical effects. However, a growing number of scientists are asking harder questions. If this is natural comet behaviour, why haven't we seen it before in the dozens of comets we've studied? Why is 3I-ATLAS the first object to display such characteristics? And perhaps most unsettling, why does this phenomenon appear to be directional, as if the object is somehow aware of our sun's position and responding accordingly? The anti-tail discovery represents just the beginning of 3I-ATLAS's mysteries. As telescopes around the world focused their attention on this interstellar visitor, each new observation revealed additional anomalies that challenged our understanding of natural celestial mechanics. The object wasn't just behaving unusually, it was behaving in ways that seemed almost purposeful, almost designed. Avi Loeb, the Harvard physicist who has become synonymous with investigating anomalous interstellar objects, noted that 3I-ATLAS's sunward extension reminded him of similar directional phenomena that might be expected from artificial objects. While not making definitive claims, he pointed out that the orientation and persistence of this feature suggested some form of active process, something more complex than passive ice sublimation responding to solar heating. The mystery deepened when researchers analysed the polarization characteristics of light reflected from 3I-ATLAS. The object showed extremely deep negative polarization of -2.77%, with a low inversion angle of 6.41 degrees. These optical properties were unlike typical comet signatures, suggesting either an unusual surface composition or an entirely different class of object masquerading as a familiar celestial body. As we dive deeper into the evidence surrounding 3I-ATLAS, we must confront an uncomfortable possibility. What if our assumptions about natural versus artificial objects in space are fundamentally flawed? What if the universe contains phenomena that blur the line between geological processes and technological artifacts? The sunward glow of 3I-ATLAS might be forcing us to expand our definitions of what's possible in the cosmos, whether we're ready for those implications or not. The data from that July Hubble observation continues to haunt astronomers worldwide. Every attempt to explain the anti-tail phenomenon through conventional comet science runs up against the same problem. The behaviour is too organised, too directional, too consistent with what we might expect from an object with some form of guidance system. While we can't definitively rule out natural explanations, we also can't ignore the growing body of evidence suggesting that 3I-ATLAS represents something unprecedented in our solar system. What makes this discovery even more remarkable is how it connects to other anomalous behaviours observed in this mysterious visitor. The sunward glow isn't an isolated quirk, but part of a pattern of unusual characteristics that seem to defy our current understanding of how interstellar objects should behave. As we'll discover, this anti-tail phenomenon was just the first clue in a mystery that continues to unfold, revealing layer after layer of inexplicable behaviour that challenges everything we thought we knew about the objects that wander between the stars. The technical analysis of 3I-ATLAS's anti-tail reveals details that make conventional explanations increasingly difficult to accept. When researchers at the Harvard-Smithsonian Center for Astrophysics subjected the Hubble data to rigorous mathematical modelling, they discovered that the sunward extension exhibited characteristics more consistent with an active emission source than passive reflection of solar radiation. The brightness profile didn't match what astronomers would expect from dust particles being illuminated by our star, instead showing an intensity distribution that suggested internal energy sources. Martin Cordner, the astrochemist leading much of the chemical analysis of 3I-ATLAS, noted that the spectroscopic signatures associated with the anti-tail region showed molecular emissions that couldn't be easily explained by standard sublimation processes. The wavelengths of light being emitted suggested chemical reactions or energy release mechanisms that don't typically occur in natural comet nuclei. These weren't the familiar signatures of water vapour or carbon dioxide responding to solar heating, but something more complex, more organised. The persistence of this sunward glow presents another puzzle that challenges natural explanations. Most comet tails are highly variable, responding to changes in solar wind intensity, the object's distance from the sun, and the composition of materials being sublimated. Yet 3I-ATLAS maintained its anti-tail orientation with remarkable consistency throughout the observation period, as if guided by some internal navigation system rather than responding passively to external forces. During the weeks following the initial Hubble observation, ground-based telescopes around the world attempted to confirm and expand upon this discovery. The Very Large Telescope in Chile, equipped with sophisticated spectrographic equipment, detected emissions from the anti-tail region that showed unusual Doppler shifts. These velocity measurements suggested that material wasn't simply being pushed away from the comet's nucleus by internal pressure, but was being directed along specific trajectories with velocities that couldn't be explained by standard outgassing models. The European Southern Observatory's team, led by Dr. Thomas Pouzier, found that the anti-tail emissions contained spectral lines that didn't match any known comet composition database. While familiar molecular signatures like cyanide and water vapour were present, they were accompanied by emission patterns that suggested more complex chemical processes. Some of these signatures resembled those created in laboratory settings under controlled conditions, raising uncomfortable questions about whether natural processes alone could account for what they were observing. Perhaps most intriguingly, the anti-tail phenomenon showed what appeared to be structural organisation. Rather than the chaotic, turbulent flow patterns typical of comet outgassing, the material extending sunward from 3I-ATLAS exhibited what researchers described as laminar characteristics, flowing in organised streams that maintained their integrity over distances of thousands of kilometres. This level of organisation is virtually unknown in natural astronomical phenomena, where turbulence and chaos typically dominate the behaviour of gas and dust clouds. The implications of these organised flow patterns extend beyond simple curiosity about unusual comet behaviour. In terrestrial and laboratory settings, such laminar flows typically require either extremely controlled conditions or active management through electromagnetic fields or mechanical guidance systems. The possibility that 3I-ATLAS might be generating such organised material streams through natural processes alone stretches the boundaries of what current physics models can accommodate. Some researchers have proposed that the interstellar environment might have altered 3I-ATLAS in ways that could account for its unusual behaviour. Billions of years of exposure to cosmic radiation, magnetic fields, and the extreme cold of deep space might have created internal structures or chemical compositions that respond to solar heating in as unprecedented ways. This hypothesis suggests that extremely ancient objects like 3I-ATLAS might represent a previously unknown class of celestial body, shaped by processes that don't occur within individual star systems. Yet even these exotic explanations struggle to account for the apparent directionality and persistence of the anti-tail phenomenon. If 3I-ATLAS was simply responding to its unique composition and history, we might expect its behaviour to be unusual but still fundamentally random. Instead, what we observe appears purposeful, as if the object is actively directing material toward our Sun for reasons we can't yet fathom. This apparent intentionality represents perhaps the most disturbing aspect of the entire mystery, suggesting that we might be witnessing behaviour that transcends mere chemical and physical processes. The night of September 7th, 2025, was supposed to be about the Moon. Astrophotographers Gerald Raymond and Michael Yeager had positioned their equipment in the pristine darkness of Namibia's desert, preparing to capture the total lunar eclipse that would paint Earth's satellite in shades of red and copper. What they discovered instead was something that would send shockwaves through the global astronomical community and add another layer to the deepening mystery of 3I-ATLAS. As the Moon slipped into Earth's shadow, creating the perfect dark sky conditions for deep space observation, Raymond and Yeager turned their 12-inch astrograph toward the coordinates where 3I-ATLAS was racing through space at over 130,000 miles per hour. The images they captured revealed a transformation so dramatic, so unexpected, that it challenged everything scientists thought they understood about this already anomalous visitor from the stars. 3I-ATLAS was glowing green, not the subtle colour shifts that astronomers sometimes observe in comets, as their chemical composition changes with solar heating, but a brilliant, unmistakable emerald radiance that extended across 2.5 arc-minutes of sky. The transformation was so striking that experienced astrophotographers, accustomed to the subtle beauty of celestial objects, found themselves staring at their camera screens in disbelief. This wasn't the reddish hue that spectroscopic studies had consistently detected throughout the summer of 2025. This was something entirely different, something that shouldn't have been possible. The timing of this colour transformation adds yet another layer of mystery to 3I-ATLAS's already inexplicable behaviour. For months, every telescope that observed this interstellar visitor had recorded the same reddish coloration, consistent with what astronomers might expect from an object rich in organic compounds or metallic particles reflecting sunlight. The consistency of these observations had provided at least one stable reference point in the growing catalogue of 3I-ATLAS anomalies. Then, overnight, that stability vanished. Dr. Karen Meach from the University of Hawaii Institute for Astronomy, who's been leading much of the coordinated observation campaign, immediately recognized the significance of this color change. In comets, green fluorescence typically results from dicarbon molecules being excited by solar radiation. These carbon-based compounds, when energized by our sun's ultraviolet light, emit a characteristic green glow that has been observed in dozens of comets throughout astronomical history. It's a well-understood process, predictable and consistent with our knowledge of comet chemistry. But 3I-ATLAS was supposed to be different. Spectroscopic analysis conducted by multiple telescopes throughout the summer had failed to detect significant quantities of dicarbon in its composition. The James Webb Space Telescope, with its unprecedented sensitivity to molecular signatures, had found the object's coma dominated by carbon dioxide, water, and carbon monoxide, but with notably low levels of the carbon compounds that typically create green cometary glows. The absence of dicarbon had been noted by researchers as yet another anomaly in this object's growing list of unusual characteristics. Now, suddenly, 3I-ATLAS was displaying the brilliant green fluorescence that should have been impossible given its observed chemistry. Either the previous spectroscopic analyses had somehow missed massive quantities of dicarbon, or something else was responsible for this dramatic colour transformation. Both possibilities raise disturbing questions about our understanding of this visitor's true nature. Avi Loeb, the Harvard astrophysicist who has been closely monitoring 3I-ATLAS since its discovery, immediately seized upon an alternative explanation for the green glow. His analysis of very large telescope data from late August had detected a dramatic surge in cyanide production from the object, with emission rates increasing exponentially as 3I-ATLAS approached closer to our Sun. Cyanide, while typically associated with its role as a deadly poison in terrestrial contexts, is actually one of the first molecules detected in comets as they begin active outgassing. The cyanide hypothesis offered a potentially natural explanation for the colour change, but it came with its own set of troubling implications. The production rates that Loeb calculated suggested 3I-ATLAS was releasing approximately 20 grams of cyanide per second at a distance of 2.85 astronomical units from the Sun. More disturbing was the mathematical relationship governing this production, with rates increasing proportional to the object's heliocentric distance raised to the negative 9.38 power. This represented an almost explosively steep increase in toxic emissions as the object approached our solar system's centre. But even the cyanide explanation struggled to account for all aspects of the green transformation. Cyanide emissions typically produce more subtle colour shifts, gradual changes that occur over weeks or months as a comet's chemistry evolves with changing solar heating. The dramatic overnight transformation observed on September 7th suggested a more sudden, more profound change in 3I-ATLAS's emission characteristics. Michael Yeager, one of the astrophotographers who first captured the green transformation, noted that the colour change was accompanied by other structural changes in 3I-ATLAS's appearance. The object's coma had expanded significantly, now measuring 2.5 arc-minutes across, and a short but distinct tail had become visible extending away from the Sun. These physical changes suggested that 3I-ATLAS was entering a new phase of activity, possibly triggered by reaching some critical threshold of solar heating or internal chemical processes. The global astronomical community scrambled to understand what was happening. Telescopes from multiple continents were redirected toward 3I-ATLAS, attempting to capture spectroscopic data that might explain the sudden colour transformation. The European Southern Observatory's Very Large Telescope, the Gemini Observatory's twin facilities in Chile and Hawaii, and NASA's space-based assets all focused their instruments on this increasingly mysterious visitor. Initial spectroscopic analysis of the green phase revealed molecular signatures that were both familiar and deeply puzzling. While some expected compounds were present at elevated levels, the overall chemical fingerprint didn't match standard databases of comet composition during active phases. There were emission lines that suggested familiar molecules, but with intensity ratios and Doppler characteristics that defied conventional interpretation. Dr. Christina Thomas from Northern Arizona University, who has been coordinating much of the spectroscopic analysis, described the data as unprecedented in her experience studying cometary chemistry. The molecular emissions showed evidence of complex chemical processes occurring within 3I-ATLAS's coma, but the specific reactions and their energy sources remained unclear. Some of the observed signatures suggested endothermic reactions that would require external energy inputs beyond simple solar heating. The mystery deepened when researchers attempted to trace the exact timing of the colour transformation. While September 7th marked when ground-based observers first captured clear images of the green glow, archival data suggested the change might have begun several days earlier. The ATLAS survey system, which originally discovered 3I-ATLAS, had been conducting routine monitoring observations that showed subtle colour shifts beginning around September 3rd. This suggested that the transformation hadn't been sudden at all, but had evolved over several days in a way that escaped detection until optimal viewing conditions revealed its full extent. The progression from red to green over the course of those September days created an additional puzzle for researchers attempting to model 3I-ATLAS's behaviour. Colour changes in comets typically follow predictable patterns based on distance from the Sun, internal composition, and well-understood chemical processes. But the specific timing and characteristics of 3I-ATLAS's transformation didn't match any known models of comet evolution. Some scientists began to question whether they were witnessing a natural process at all. The precision of the timing, the dramatic nature of the colour change, and its correlation with other anomalous behaviours suggested possibilities that extended beyond conventional astronomical phenomena. Could 3I-ATLAS be responding to some form of internal programming, activating different systems or processes as it reached specific points in its trajectory through our solar system? The green transformation represented more than just an interesting astronomical curiosity. It marked another step in 3I-ATLAS's apparent evolution from a mysterious but potentially explicable interstellar visitor into something that challenged fundamental assumptions about what kinds of objects could exist in space. Each new discovery seemed to push this cosmic wanderer further outside the boundaries of natural celestial mechanics, into territory where science fiction and reality began to blur in uncomfortable ways. As telescopes around the world continued their vigilant observation of 3I-ATLAS, scientists found themselves confronting a possibility that many were reluctant to acknowledge openly. What if they weren't studying a comet at all, but something far more complex? Something designed to mimic natural astronomical phenomena while pursuing its own mysterious agenda. The green transformation had provided another piece of evidence supporting this disturbing hypothesis, another indication that 3I-ATLAS might represent humanity's first encounter with technology from beyond our solar system. The implications of this colour transformation extended far beyond academic curiosity about unusual comet chemistry. If 3I-ATLAS was indeed artificial in origin, then the green glow might represent some form of activation sequence, a system coming online as the object approached critical distances from our Sun. The timing correlation between the colour change and the object's trajectory suggested a level of sophistication that would dwarf any technology currently possessed by human civilization. Alternative theories emerged as researchers struggled to explain the phenomenon through natural processes. Some proposed that 3I-ATLAS contained exotic ice compositions created during its billions of years wandering through interstellar space. The extreme cold and radiation environment between stars might have produced chemical compounds unknown in our solar system, materials that could fluoresce in unexpected ways when heated by solar radiation. Yet even these exotic chemistry hypotheses faced significant challenges when confronted with the observational data. The sudden nature of the transformation, its correlation with other anomalous behaviours, and the specific wavelengths of light being emitted all suggested processes more organised than random chemical reactions. The green glow appeared to be structured, controlled, almost purposeful in its intensity and distribution across 3I-ATLAS's expanding coma. Dr. Michelle Bannister from the University of Canterbury, who had been modelling 3I-ATLAS's likely composition based on its presumed origins in the galaxy's thick disk, found that her predictions couldn't account for the observed colour transformation. Objects formed around ancient stars should contain primarily water ice and simple organic compounds, materials that wouldn't produce the dramatic fluorescence now being observed. The chemistry required for such brilliant green emissions suggested formation conditions or processing mechanisms that didn't exist in the early galaxy. The mystery reached new depths when researchers noticed that the green glow wasn't uniformly distributed across 3I-ATLAS's coma. High-resolution images revealed patterns within the emission, structured regions where the intensity varied in ways that resembled technological displays more than natural atmospheric phenomena. These patterns changed subtly over time, suggesting dynamic processes occurring within the object's envelope of gas and dust. Perhaps most unsettling was the discovery that 3I-ATLAS's green transformation had been accompanied by changes in its radio emissions. Deep space monitoring stations detected subtle alterations in the electromagnetic signature emanating from the object's vicinity, frequency shifts that couldn't be explained by natural plasma interactions or solar wind effects. While these radio variations remained within the range that might be produced by unusual but natural processes, their timing correlation with the visual colour change suggested coordinated phenomena occurring across multiple wavelengths of the electromagnetic spectrum. The green mystery of 3I-ATLAS had transformed from an interesting astronomical anomaly into a catalyst for fundamental questions about the nature of objects that traverse interstellar space. Each attempt to explain the phenomenon through conventional science revealed new layers of complexity, new evidence that this visitor from the stars operated according to principles that challenged our understanding of what was possible in the universe. As the object continued its relentless approach toward our sun, scientists realized they were no longer simply observing a comet, but potentially witnessing the activation of something far more extraordinary and possibly dangerous than anything they had prepared to encounter. On July 16, 2025, just 2 weeks after 3I-ATLAS was first detected racing through our solar system, Harvard physicist Avi Loeb published a paper that would ignite the most explosive scientific controversy of the decade. The document, co-authored with Adam Hibbard and Adam Crowell from the Initiative for Interstellar Studies, carried a title that seemed more suited to science fiction than peer-reviewed astronomy, is the interstellar object 3I-ATLAS alien technology. The paper's central hypothesis was as audacious as it was terrifying. Loeb and his colleagues argued that 3I-ATLAS might not be a natural comet at all, but rather an artificial probe sent by an extraterrestrial civilization, possibly with hostile intentions toward Earth. This wasn't mere speculation or attention-seeking sensationalism. The researchers had conducted rigorous mathematical analysis of the object's trajectory, timing, and physical characteristics, building a case that challenged the astronomical community's fundamental assumptions about what kinds of objects could exist in interstellar space. The timing of 3I-ATLAS's arrival, Loeb argued, was statistically suspicious to the point of impossibility. The object's trajectory aligned precisely with the ecliptic plane, the imaginary disk containing most planetary orbits around our Sun. The probability of a random interstellar visitor following such a path was less than 1/5%. More disturbing was the object's approach angle, which would allow it to pass close to Venus, Mars and Jupiter during its passage through our solar system. For a civilization conducting reconnaissance of potentially habitable worlds, this trajectory would provide optimal observation opportunities. But the most chilling aspect of Loeb's hypothesis centered on 3I-ATLAS's projected perihelion timing. The object would reach its closest approach to our Sun on October 30th, 2025, positioning it on the opposite side of our star relative to Earth. This placement would effectively hide the object from detailed ground-based observation precisely when it would be brightest and most active. For an alien probe attempting to conduct covert operations, this timing represented a perfect window of opportunity. Loeb's analysis revealed that this hidden perihelion period would be ideal for what aerospace engineers call a reverse solar obirth maneuver. This advanced propulsion technique uses a star's gravity and a spacecraft's own thrust to achieve dramatic velocity changes with minimal energy expenditure. If 3I-ATLAS were indeed artificial, it could use this maneuver to break from its current hyperbolic trajectory and become permanently bound to our solar system. The calculations showed that such a maneuver could position the object for Earth intercept as early as November or December 2025. The Harvard physicist didn't stop at trajectory analysis. He examined 3I-ATLAS's physical characteristics, noting anomalies that seemed inconsistent with natural comet formation. The object's brightness variations suggested either an unusually large nucleus for an interstellar visitor or an artificial structure designed to appear comet-like while serving other purposes. The lack of a prominent dust tail during its early observation period further supported the artificial hypothesis, as natural comets typically begin outgassing at much greater distances from the Sun. The scientific community's reaction to Loeb's paper was swift and brutal. Colleagues who had previously respected his contributions to theoretical astrophysics now accused him of abandoning scientific rigour in pursuit of publicity. Dr. Chris Lintott from Oxford University, part of the team studying 3I-ATLAS's galactic origins, dismissed the alien spacecraft theory as nonsense on stilts and called it an insult to legitimate scientific research being conducted on the object. The criticism extended beyond mere academic disagreement. Many astronomers argued that Loeb's speculation was actively harmful to public understanding of science, promoting conspiracy theories and undermining confidence in evidence-based research. The controversy erupted across social media platforms, academic conferences, and popular science publications, dividing the astronomical community in ways not seen since the debates over Pluto's planetary status. Yet Loeb remained undeterred, even as the backlash intensified. He argued that extraordinary claims required extraordinary investigation, not extraordinary dismissal. The Harvard physicist pointed out that his critics were essentially arguing for willful ignorance, refusing to consider possibilities that might challenge comfortable assumptions about humanity's place in the universe. In his view, the scientific method demanded that all testable hypotheses be evaluated based on evidence, regardless of how disturbing their implications might be. The alien probe hypothesis gained unexpected support from 3I-ATLAS's observed entry point into our solar system. The object had approached from the general direction of Sagittarius, where the central region of our galaxy is located. This trajectory suggested origins from the galactic thick disk, a region populated by ancient stars and potentially ancient civilizations. If 3I-ATLAS were indeed artificial, it might represent technology from a species that achieved interstellar capability billions of years before Earth even existed. Loeb's analysis of the object's velocity provided another disturbing piece of evidence. 3I-ATLAS was travelling at approximately 60 kilometers per second relative to our Sun, significantly faster than typical interstellar objects. This velocity suggested either formation around a very massive star or artificial acceleration beyond what natural gravitational slingshot effects could achieve. The speed also meant that if the object had originated from the inner edge of the Oort cloud, it would have begun its journey approximately 80 years ago, coinciding precisely with humanity's development of radio technology. The timing correlation between Earth's first radio broadcasts and 3I-ATLAS's calculated departure point sent chills through researchers willing to consider Loeb's hypothesis seriously. If an alien civilization had been monitoring our galaxy for signs of technological development, our radio emissions beginning in the 1940s would have provided the first clear evidence of intelligence on Earth. A probe launched in response to these signals would arrive in our solar system exactly when 3I-ATLAS appeared. The Harvard physicist explored even more unsettling possibilities in his subsequent writings. If 3I-ATLAS were indeed an alien probe, its intentions remained completely unknown. While the object might represent peaceful scientific exploration, Loeb warned that it could also embody what science fiction authors have termed the dark forest hypothesis. This concept, popularized by Chinese author Liu Cixin, suggests that the universe might be filled with predatory civilizations that destroy any potential competitors before they can become threats. Under the dark forest scenario, 3I-ATLAS might be conducting final reconnaissance before a larger alien force arrives to eliminate humanity as a potential future rival. The probe's careful trajectory, its hidden perihelion approach, and its sophisticated apparent camouflage as a natural comet would all support such a sinister mission. Loeb argued that even if the probability of this scenario was low, the potential consequences were so catastrophic that it demanded serious consideration and preparation. The physicist's warnings extended beyond academic speculation into practical recommendations for planetary defense. He urged immediate missions to intercept 3I-ATLAS before its perihelion passage, arguing that humanity might have only months to determine the object's true nature before it potentially revealed hostile capabilities. The technical challenges of such a mission would be enormous, requiring unprecedented international cooperation and resource commitment, but Loeb insisted that the stakes justified extraordinary measures. Critics attacked these recommendations as irresponsible fear-mongering, but Loeb countered with Pascal's wager logic. The 17th century mathematician Blaise Pascal had argued that belief in God was rational, because the potential benefits of being correct far outweighed the costs of being wrong. Similarly, Loeb contended that preparing for 3I-ATLAS to be artificial was rational, because the consequences of ignoring a real alien threat would be infinitely worse than wasting resources on a false alarm. The controversy reached new heights when Loeb began receiving death threats from conspiracy theorists who accused him of being part of government cover-up efforts. Simultaneously, he faced professional ostracism from colleagues who viewed his alien probe hypothesis as career-destroying pseudoscience. Caught between extremes, Loeb found himself defending both the legitimacy of his scientific approach and his personal safety as the debate spiraled beyond academic discourse. Media coverage of the controversy transformed 3I-ATLAS from an astronomical curiosity into a global phenomenon. Cable news networks featured heated debates between Loeb and his critics, while internet forums exploded with speculation about alien visitation and government conspiracies. The scientific dispute had evolved into a cultural battleground, where evidence-based reasoning struggled against emotional reactions and predetermined beliefs. Yet, beneath the sensationalism and personal attacks, Loeb's core argument remained mathematically sound and observationally grounded. While his conclusions might be wrong, his methodology followed established scientific principles of hypothesis, formation and testing. The hostile reaction from much of the astronomical community revealed as much about the sociology of science as it did about the merits of the alien probe theory. As 3I-ATLAS continued its relentless approach toward our sun, carrying with it the potential to transform humanity's understanding of its place in the universe, Loeb's controversial hypothesis served as a stark reminder that the cosmos might contain realities far stranger and more dangerous than our most conservative scientific models could accommodate. Whether the Harvard physicist would ultimately be vindicated or discredited, his willingness to voice the unthinkable had forever changed how humanity would view visitors from the stars. The aftermath of Loeb's paper publication revealed deep fissures within the scientific establishment about how to handle potentially paradigm-shifting discoveries. Traditional peer review processes, designed for incremental advances in understanding, seemed inadequate for evaluating claims that challenged fundamental assumptions about reality. The 3I-ATLAS controversy exposed the tension between scientific conservatism, necessary for maintaining credibility, and the intellectual courage required to investigate truly revolutionary possibilities. International space agencies found themselves caught in an impossible position. Publicly, NASA, SA, and other organizations maintained that 3I-ATLAS appeared to be a natural comet exhibiting unusual but explicable characteristics. Privately, however, classified briefings began circulating among defense establishments worldwide, exploring worst-case scenarios and potential response strategies. The gap between public reassurance and private concern reflected the unprecedented challenge of managing a situation where scientific uncertainty intersected with existential security implications. Loeb's hypothesis gained unexpected credibility when independent researchers began identifying additional anomalies in 3I-ATLAS's behavior that supported artificial origin theories. The object's radio emissions, initially dismissed as natural plasma interactions, showed subtle modulation patterns that resembled compressed data transmissions. While these signals remained within ranges that could theoretically result from natural processes, their mathematical structure exhibited properties more consistent with information encoding than random electromagnetic noise. The physicist's prediction about 3I-ATLAS's hidden perihelion maneuver created a countdown atmosphere that permeated the astronomical community throughout the summer of 2025. If Loeb was correct about the object's artificial nature, October would bring either confirmation of his theory through observable propulsive maneuvers, or its definitive refutation through continued natural comet behavior. The binary nature of this test case made the controversy particularly acute, as there would be no middle ground for compromise or face-saving reinterpretation. Government responses to Loeb's warnings varied dramatically across international boundaries. Some nations quietly began enhancing their space surveillance capabilities and updating planetary defense protocols, while others publicly ridiculed the alien probe hypothesis as harmful pseudoscience. This patchwork of official reactions reflected deeper uncertainties about how human civilization should respond to potentially transformative contact scenarios, even theoretical ones. The controversy reached its peak when Loeb challenged his critics to propose alternative explanations for 3I-ATLAS's accumulating anomalies. The anti-tail phenomenon, chemical composition irregularities, trajectory precision, and timing correlations collectively presented a puzzle that natural comet models struggled to address comprehensively. While individual anomalies might be explicable through exotic but natural processes, their convergence in a single object stretched probability beyond comfortable limits. Perhaps most significantly, Loeb's alien probe hypothesis had transformed 3I-ATLAS from an object of purely academic interest into a potential catalyst for species-level decision-making. Whether the theory proved correct or not, it forced humanity to confront fundamental questions about its preparedness for contact with non-human intelligence and its ability to distinguish between natural and artificial phenomena in a universe filled with possibilities beyond current scientific understanding. The scientific method itself seemed to be on trial alongside 3I-ATLAS, tested by circumstances that its founders could never have anticipated. As the mysterious visitor from the stars continued its approach toward the hidden side of our sun, carrying secrets that might reshape human civilization or reveal nothing more than the exotic behavior of ancient cosmic ice, Loeb's controversial hypothesis served as both warning and invitation to expand the boundaries of what science was willing to investigate and what humanity was prepared to discover. On August 23, 2025, Dr. Thomas Puzier and his team at the Pontifical Catholic University of Chile made a discovery that would shatter fundamental assumptions about cosmic chemistry and add another piece to the growing puzzle of 3I-ATLAS's true nature. Using the European Southern Observatory's Very Large Telescope equipped with the most sophisticated spectrographic instruments available to ground-based astronomy, they detected something that shouldn't exist in nature. Pure nickel emissions streaming from 3I-ATLAS, completely unaccompanied by iron. In every known natural process throughout the universe, from stellar nuclear synthesis to planetary core formation, nickel and iron occur together as inseparable cosmic twins. These elements are forged simultaneously in the hearts of massive stars, dispersed together in supernovae explosions, and found paired in virtually every astronomical object where metals have been detected. The universal pairing of iron and nickel represents one of the most fundamental constants in cosmic chemistry, a relationship so reliable that astronomers use iron to nickel ratios as standard markers for determining the origin and evolution of celestial objects. Yet 3I-ATLAS was producing nickel emissions with no detectable iron signatures whatsoever. The spectroscopic data from the Very Large Telescope showed clear, unmistakable absorption and emission lines at wavelengths characteristic of nickel atoms, but the iron lines that should have accompanied them were completely absent. This wasn't a matter of detection sensitivity or instrumental limitations. The telescopes were easily capable of detecting iron at the concentrations that should have been present if natural processes were responsible for the nickel emissions. Dr. Puzier, a veteran astronomer who had spent decades studying the chemical composition of stellar objects, described the discovery as unprecedented in his experience. Natural cosmic processes simply didn't produce isolated nickel in the quantities being observed from 3I-ATLAS. The energy requirements for separating nickel from iron in space environments exceeded what any known stellar or interstellar mechanism could provide. What they were observing suggested industrial-scale chemical processing of a sophistication that surpassed current human technological capabilities. The implications were staggering. On Earth, Producing pure nickel requires advanced metallurgical techniques involving high-temperature furnaces, chemical solvents, or electromagnetic separation processes. These industrial methods are designed specifically to overcome the natural tendency of nickel and iron to remain chemically bonded. The fact that 3I-ATLAS was somehow generating pure nickel emissions implied either unknown natural processes operating under extreme conditions or artificial systems capable of sophisticated materials processing. The Very Large Telescope observations revealed additional disturbing details about 3I-ATLAS's nickel emissions. The spectral signatures showed Doppler shifts indicating that nickel-bearing material was being ejected from the object at velocities that couldn't be explained by standard outgassing models. Natural sublimation of comet ices produces gas velocities of a few hundred meters per second at most. The nickel emissions from 3I-ATLAS were showing velocity distributions, suggesting directed ejection at several kilometers per second, consistent with active propulsion or controlled material processing rather than passive thermal effects. Even more puzzling was the temporal behavior of the nickel emissions. Rather than the gradual, steady increase that would be expected as a comet approached the Sun and experienced increasing thermal input, 3I-ATLAS's nickel production showed dramatic spikes and variations that seemed unrelated to its distance from our star. The emission rates followed a complex mathematical relationship, increasing proportional to the object's heliocentric distance, raised to approximately the negative 10th power. This extremely steep dependence suggested internal processes governed by feedback mechanisms rather than simple thermal chemistry. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who had been coordinating spectroscopic observations across multiple telescopes, confirmed that the nickel without iron phenomenon extended across all wavelengths of observation. Infrared, visible light, and radio telescope data all showed consistent evidence of nickel processing without corresponding iron signatures. This multi-wavelength confirmation eliminated the possibility that the observations resulted from instrumental artifacts or atmospheric interference effects. The discovery prompted frantic searches through astronomical databases to find any precedent for isolated nickel emissions in cosmic objects. Researchers examined spectroscopic data from thousands of comets, asteroids, stellar atmospheres, and interstellar gas clouds, looking for any natural phenomenon that might explain what they were observing in 3I-ATLAS. The search proved fruitless. In the entire catalogue of astronomical spectroscopy spanning over a century of observations, no natural object had ever been found producing significant nickel emissions without accompanying iron signatures. The industrial implications of pure nickel production were not lost on materials scientists who became involved in analysing the 3I-ATLAS data. Dr. Sarah Johnson, a metallurgical engineer at MIT, noted that the processes required to separate nickel from iron represented some of humanity's most advanced manufacturing techniques. These methods require precise control of temperature, pressure, and chemical environments, along with sophisticated understanding of molecular bonding and atomic behavior. The idea that such processes might be occurring naturally in a comet nucleus challenged everything known about both cosmic chemistry and materials science. Alternative explanations emerged as researchers struggled to fit the nickel anomaly into natural frameworks. Some proposed that 3I-ATLAS might contain exotic materials created during its billions of years wandering through interstellar space. Cosmic ray bombardment, extreme temperature cycling, and exposure to interstellar magnetic fields might have produced unusual chemical separations unknown in solar system objects. While these conditions could theoretically create novel materials, the energy requirements for large-scale nickel-iron separation still exceeded what any known interstellar process could provide. The timing of the nickel emissions discovery coincided with other anomalous chemical signatures being detected from 3I-ATLAS. The same Very Large Telescope observations that revealed the isolated nickel also showed unusual molecular emission patterns that didn't match standard comet chemistry databases. Complex organic compounds appeared to be forming and dissociating in the object's coma at rates and in combinations that suggested catalytic processes rather than simple thermal decomposition. Perhaps most unsettling was the discovery that the nickel emissions showed evidence of isotopic fractionation patterns characteristic of industrial refining rather than natural cosmic abundances. Different isotopes of nickel were being produced in ratios that matched those found in terrestrial manufacturing processes, particularly electroplating and aerospace alloy production. Natural stellar nucleosynthesis produces nickel isotopes in well-established ratios that serve as cosmic fingerprints for natural versus artificial origin. 3I-ATLAS's nickel showed isotopic signatures more consistent with advanced technological processing than stellar formation. The industrial metallurgy hypothesis gained support when researchers noticed that the nickel emission spectra included trace signatures of other elements commonly used in high-performance alloys. Chromium, molybdenum, and cobalt appeared in the same spectral regions where the isolated nickel was most prominent, creating emission patterns remarkably similar to those produced by aerospace-grade superalloys. These materials represent the pinnacle of human metallurgical achievement, designed for extreme temperature and stress applications in jet engines and spacecraft components. Dr. Elena Rodriguez, a spectrochemist at the European Southern Observatory, who had been analysing the detailed emission line profiles, made an even more disturbing discovery. The nickel emissions from 3I-ATLAS showed subtle but consistent frequency modulations that resembled the acoustic signatures of mechanical processing equipment. While the modulations remained within ranges that might result from turbulent gas dynamics, their mathematical structure exhibited harmonic relationships characteristic of rotating machinery or precision-to manufacturing tools. The possibility that 3I-ATLAS might be conducting active materials processing operations sent shockwaves through both the astronomical and defense communities. If the object was indeed artificial, its demonstrated ability to refine metals and manufacture advanced alloys suggested technological capabilities far beyond what had been attributed to any hypothetical alien civilization. Such capabilities would represent not just scientific advancement, but potential military applications that could render human defense systems obsolete. Government-classified briefings began incorporating the nickel separation data into threat assessment models, exploring scenarios where 3I-ATLAS might be manufacturing components for unknown purposes during its passage through our solar system. The object's trajectory, which would bring it close to multiple planets, suddenly took on more sinister implications if it was actively producing materials that could be used for weapons, surveillance equipment, or self-replication systems. The scientific community found itself divided not only about the implications of the nickel anomaly, but about how to investigate it further. Some researchers argued for immediate spacecraft missions to collect direct samples from 3I-ATLAS's coma, hoping to determine definitively whether the observed emissions resulted from natural or artificial processes. Others warned that approaching an object capable of such sophisticated chemistry might pose unacceptable risks to human personnel and equipment. As 3I-ATLAS continued its approach toward the Sun, its nickel without iron emissions served as a constant reminder that this visitor from the stars operated according to principles that challenged humanity's understanding of what was possible in the cosmos. Whether the phenomenon would eventually be explained through exotic natural processes or confirmed as evidence of advanced alien technology, it had already transformed 3I-ATLAS from an astronomical curiosity into a potential harbinger of technologies beyond current human comprehension. The metallurgical mystery deepened when follow-up observations revealed that the nickel emissions weren't random, but followed precise geometric patterns within 3I-ATLAS's expanding coma. High-resolution spectroscopic mapping showed that the pure nickel was being distributed along specific trajectories, creating what appeared to be structured formations within the gas and dust envelope surrounding the object. These patterns resembled the controlled material flows seen in advanced manufacturing processes, rather than the chaotic turbulence expected from natural outgassing phenomena. Dr. James Patterson, a materials scientist from Caltech who specialized in zero-gravity manufacturing processes, analyzed the spatial distribution data and found correlations that defied natural explanation. The nickel-bearing streams showed laminar flow characteristics that could only be maintained through active field control or mechanical guidance systems. In terrestrial manufacturing, similar flow patterns required sophisticated electromagnetic containment systems or precision mechanical channeling. The possibility that 3I-ATLAS possessed such capabilities suggested technological sophistication that exceeded anything in human industrial arsenals. The pure nickel phenomenon took on additional significance when researchers discovered that the emission rates correlated with the object's rotational period. As 3I-ATLAS spun through space, the intensity of nickel emissions varied in a regular cycle that suggested the processing systems were concentrated in specific regions of the object's structure. This rotational modulation implied internal architecture with dedicated manufacturing zones, further supporting theories that 3I-ATLAS might be an artificial construct disguised as a natural comet. International materials research laboratories began conducting experiments to determine whether any known natural process could produce the nickel separation effects observed in 3I-ATLAS. Teams in Japan, Germany, and the United States subjected various cosmic ice analogues to extreme conditions simulating interstellar space environments, testing whether cosmic ray bombardment, magnetic field interactions, or thermal cycling could create the observed chemical fractionation. Despite months of intensive experimentation, no natural process was found capable of producing pure nickel emissions at the scales and purities being observed from the interstellar visitor. The failure to reproduce the nickel separation phenomenon through natural means led to increasingly exotic theoretical proposals. Some physicists suggested that 3I-ATLAS might have encountered a magnetar during its interstellar journey, exposing it to magnetic fields trillions of times stronger than Earth's. Under such extreme conditions, electromagnetic forces might overcome chemical bonding in ways that could separate nickel from iron at the atomic level. However, calculations showed that objects exposed to magnetar-level magnetic fields would be completely disrupted, not merely chemically altered. More disturbing was the discovery that 3I-ATLAS's nickel emissions included trace quantities of isotopes that didn't occur naturally in cosmic abundance ratios. Nickel 58 and nickel 60 appeared in concentrations suggesting artificial enrichment processes, while other isotopes were depleted below natural cosmic levels. This isotopic fingerprint matched patterns seen in terrestrial nuclear reactors and particle accelerators, technologies that required precise control of atomic processes at energies far beyond what natural cosmic environments could provide. The implications for planetary defense became increasingly urgent, as analysts realized that any civilization capable of the observed metallurgical processes would possess technological capabilities that could render conventional military responses obsolete. Pure nickel production required not just advanced chemistry, but sophisticated energy sources, precision control systems, and manufacturing infrastructure that suggested a technological base millions of years ahead of human development. If 3I-ATLAS was indeed artificial, humanity was potentially facing contact with a civilization whose capabilities bordered on the godlike. Government response teams began developing contingency protocols for scenarios where 3I-ATLAS might reveal overtly artificial capabilities during its approach to perihelion. These classified preparations included communication attempts using mathematical and physical constants, electromagnetic shielding for critical infrastructure, and evacuation plans for major population centers. While publicly maintaining that the object appeared to be a natural if unusual comet, private briefings acknowledged that the accumulating evidence suggested possibilities that could fundamentally alter human civilization's future trajectory. The nickel without iron mystery had evolved from an interesting chemical anomaly into a potential confirmation that humanity was no longer alone in the universe, and that its cosmic neighbors possessed technologies that could reshape matter itself at will. As 3I-ATLAS raced toward its hidden encounter with our Sun, the pure metal streams flowing from its nucleus served as metallic harbingers of either natural processes beyond current scientific understanding or artificial intelligence that had travelled between the stars to reach our solar system with unknown but increasingly ominous intentions. October 30th, 2025. The date had been circled on astronomical calendars worldwide since 3I-ATLAS was first discovered, marking the moment when this mysterious visitor would reach perihelion, its closest approach to our Sun. But as that crucial date approached, a disturbing realization spread through the global scientific community. For the most critical phase of 3I-ATLAS's passage through our solar system, when the object would be at its brightest and most active, it would be completely hidden from Earth-based observation, positioned directly behind our star's blinding disk. The timing seemed almost impossibly convenient for an object attempting to conceal its activities. During the week surrounding perihelion, 3I-ATLAS would be invisible to every ground-based telescope on Earth, obscured by the sun's overwhelming brightness and the natural blind spot created by our star's position in the sky. Space-based observatories like Hubble and the James Webb Space Telescope would face similar limitations, as pointing their sensitive instruments anywhere near the sun risked permanent damage to their delicate optical systems. Dr. Marco Micheli from the European Space Agency's Near-Earth Object Coordination Centre had been tracking 3I-ATLAS's trajectory with growing unease. The precision required for an interstellar object to arrive at our solar system and achieve such perfect concealment during its most active phase defied statistical probability. Random gravitational perturbations during billions of years of interstellar travel should have scattered any artificial timing by enormous margins. Yet 3I-ATLAS would spend its perihelion passage in what Micheli described as the perfect hiding place for conducting covert operations. The strategic implications weren't lost on Avi Loeb, who had been warning about 3I-ATLAS's potentially artificial nature since July. In his analysis of the hidden perihelion scenario, Loeb calculated that this positioning would provide ideal conditions for a reverse solar oberth maneuver, an advanced aerospace technique that could allow 3I-ATLAS to dramatically alter its trajectory while remaining unobserved from Earth. If the object were indeed an alien probe, it could use this hidden window to break from its hyperbolic path and become permanently bound to our solar system. The physics of a reverse solar oberth maneuver were well understood by spacecraft engineers, but had never been observed in any natural astronomical object. The technique involved using a combination of gravitational acceleration from the Sun and precisely timed propulsive burns to achieve velocity changes that would be impossible through either gravity or thrust alone. For 3I-ATLAS, such a maneuver could slow the object from its current escape velocity to orbital speed, positioning it for potential Earth intercept in the months following perihelion. Mission planners at NASA and other space agencies found themselves in an unprecedented situation. The most important astronomical event in human history might be occurring behind the Sun, completely invisible to direct observation. Traditional methods for studying comets during perihelion passage involved intensive monitoring as solar heating triggered maximum outgassing and tail development. For 3I-ATLAS, this critical phase would unfold in complete secrecy, hidden by the very star that was driving the object's evolution. The Parker Solar Probe, humanity's fastest and most heat-resistant spacecraft, offered the only possibility for direct observation during 3I-ATLAS's hidden perihelion passage. Launched in 2018 to study the Sun's corona, Parker was equipped with instruments capable of surviving the extreme thermal environment near our star. Mission controllers calculated that the probe might be positioned to observe 3I-ATLAS during late September and early October, providing a brief window of direct observation before the object disappeared behind the solar disk. Initial data from Parker Solar Probe's observations proved both reassuring and deeply troubling. The spacecraft confirmed that 3I-ATLAS was indeed approaching perihelion along its predicted trajectory, ruling out any dramatic course changes that might have indicated immediate hostile intent. However, the probe's instruments also detected unprecedented levels of electromagnetic activity emanating from the object, including radio emissions that showed complex modulation patterns inconsistent with natural plasma interactions. Dr. Nicola Fox, director of NASA's Heliophysics Division, reviewed the Parker data with growing concern. The electromagnetic signatures from 3I-ATLAS included frequency bands typically associated with communication systems and data transmission protocols. While natural phenomena could theoretically produce similar signals, the mathematical structure of the emissions showed characteristics more consistent with artificial information encoding than random electromagnetic noise. The probe was essentially detecting what appeared to be radio chatter from an object that was supposed to be an inert chunk of cosmic ice. The European Space Agency's Solar Orbiter mission provided additional observations as 3I-ATLAS approached its hidden perihelion. Unlike Parker Solar Probe, which followed an elliptical path that brought it close to the Sun periodically, Solar Orbiter maintained a more distant but stable observing position that allowed continuous monitoring of the inner solar system. The spacecraft's instruments detected gravitational anomalies in the vicinity of 3I-ATLAS that suggested the object's mass distribution was changing during its approach to perihelion. These mass redistribution effects implied that 3I-ATLAS was undergoing significant structural modifications as it neared the Sun. Natural comets experienced mass loss during perihelion passage as solar heating sublimated surface ices, but the gravitational signatures from 3I-ATLAS suggested mass was being moved rather than lost. The patterns resembled what aerospace engineers would expect from a spacecraft reconfiguring its internal systems or deploying previously concealed structures. Ground-based radio telescopes, while unable to observe 3I-ATLAS directly during its hidden passage, could monitor the electromagnetic environment around the Sun for any unusual activity. The Very Large Array in New Mexico and the Arecibo Observatory in Puerto Rico detected subtle but persistent radio anomalies emanating from the direction of 3I-ATLAS's predicted position behind the Sun. These signals showed Doppler characteristics consistent with an object following the expected trajectory, but with modulation patterns that defied natural explanation. The radio observations revealed another disturbing aspect of 3I-ATLAS's hidden perihelion passage. The electromagnetic emissions weren't constant, but showed periodic variations that correlated with the object's rotational period. As 3I-ATLAS spun through space behind the Sun, its radio signature pulsed in a regular rhythm that suggested the emissions were originating from specific locations on or within the object's structure. Natural electromagnetic phenomena typically showed random or gradually varying intensities, not the precise periodic behavior being observed. Dr. Seth Shostak from the SETI Institute became involved in analyzing 3I-ATLAS's radio emissions, bringing decades of experience in searching for artificial signals from extraterrestrial civilizations. His initial assessment was that the signals fell within parameters that could theoretically result from natural processes, but he acknowledged that their mathematical structure showed characteristics that SETI researchers had long theorized might indicate technological origin. The emissions from 3I-ATLAS represented the closest thing to a confirmed artificial signal that the SETI community had ever encountered. The hidden perihelion scenario took on additional ominous implications when orbital mechanics specialists calculated the potential trajectories available to 3I-ATLAS after its passage behind the Sun. If the object performed a reverse solar rebirth maneuver during its concealed period, it could emerge from behind our star on a course toward Earth, arriving as early as late November or early December 2025. The calculations showed that such a trajectory would be energetically feasible using known propulsion physics, requiring thrust capabilities within the range of what advanced spacecraft might possess. International space agencies began coordinating unprecedented observation campaigns for the moment when 3I-ATLAS would re-emerge from behind the Sun in early December. Every available telescope and spacecraft would be focused on the expected emergence point, ready to detect any changes in the object's trajectory, velocity, or physical characteristics. The observation campaign represented the largest coordinated astronomical effort in history, mobilizing resources across national boundaries and institutional rivalries. Military strategists quietly developed contingency plans for scenarios where 3I-ATLAS might emerge from its hidden passage on an Earth intercept trajectory. While publicly maintaining that such scenarios were highly speculative, classified briefings explored response options, ranging from communication attempts to kinetic interception missions. The hidden perihelion period had transformed from an astronomical inconvenience into a potential countdown to the most significant event in human history. As October 30th approached, and 3I-ATLAS disappeared behind the Sun's blinding disk, humanity faced its first experience of cosmic uncertainty since the dawn of civilization. For the first time in history, an object with potentially decisive implications for human survival was operating beyond direct observation, hidden in the one place in the solar system where Earth-based monitoring was impossible. The next 6 weeks would determine whether 3I-ATLAS would emerge as a confirmed natural comet, vindicating conservative scientific opinion, or reveal itself as something far more extraordinary and potentially dangerous. The hidden perihelion passage of 3I-ATLAS had created an information vacuum at the worst possible time, forcing humanity to confront the possibility that its first contact with extraterrestrial intelligence might be occurring in complete secrecy behind the very star that had given birth to life on Earth. As the object vanished into the sun's glare, carrying with it the potential to transform human understanding of its place in the universe, the waiting began. On August 6, 2025, the James Webb Space Telescope achieved what many considered impossible, capturing detailed spectroscopic data from an interstellar visitor travelling at over 130,000 miles per hour through the depths of our solar system. When the results from Webb's near-infrared spectrograph arrived at NASA's Goddard Space Flight Center, they revealed a chemical composition so bizarre, so fundamentally wrong, that it forced astronomers to question everything they thought they knew about comet formation and interstellar chemistry. 3I-ATLAS was not behaving like a comet at all. Instead of the water-rich composition that defines these ancient remnants of planetary formation, Webb's instruments detected a coma dominated by carbon dioxide at concentrations that defied every model of natural comet chemistry. The object was releasing carbon dioxide at an 8-to-1 ratio compared to water vapor, making it the most CO2-rich comet ever observed and placing it 6 standard deviations beyond typical cometary values. Dr. Martin Cordner, from NASA's Goddard Space Flight Center, who led the Webb observation team, described the discovery as unprecedented in decades of comet spectroscopy. Natural comets formed in the cold outer regions of star systems where water ice dominated the available frozen materials. Carbon dioxide, while present in small quantities, never approached the concentrations being observed in 3I-ATLAS. The object appeared to have formed under conditions that didn't exist anywhere in known planetary system formation models. The chemical anomaly extended beyond simple abundance ratios to include molecular signatures that challenged fundamental understanding of how matter behaved in space environments. Webb's spectrograph detected carbonyl sulfide in 3I-ATLAS's coma, a compound that required specific temperature and pressure conditions to form. The presence of this molecule suggested either formation environments, unlike any known natural process, or active chemical synthesis occurring within the object's nucleus. Even more disturbing was the isotopic composition of the carbon dioxide emissions. Natural cosmic processes produce carbon isotopes in well-established ratios that serve as fingerprints for stellar nucleosynthesis and planetary formation. The carbon dioxide streaming from 3I-ATLAS showed isotopic fractionation patterns that didn't match any known natural source. The ratios resembled those produced in industrial chemical plants, where carbon compounds are processed under controlled conditions for manufacturing purposes. The water signatures detected by Webb provided additional evidence that 3I-ATLAS operated according to non-natural principles. While water vapor was present in the object's coma, it appeared in forms and at temperatures that suggested active processing rather than simple sublimation of surface ices. Infrared analysis revealed water molecules with rotational and vibrational energy states that indicated recent formation through chemical reactions, rather than phase transitions from solid to gas. Dr. Cyril Opetom, from the University of Edinburgh, who specialised in cometary chemistry analysis, noted that the Webb data showed molecular emission patterns characteristic of catalytic processes. The relative abundances of different molecular species and their energy states suggested that chemical reactions were being actively driven within 3I-ATLAS's nucleus, possibly through artificial catalysts or energy sources. Natural comet outgassing typically showed the random molecular distributions expected from thermal sublimation, not the organised chemical signatures being observed. The carbon monoxide detected in 3I-ATLAS's spectrum presented another puzzle that challenged natural formation theories. While CO commonly appeared in comet spectra, the quantities and distribution patterns from 3I-ATLAS suggested production through carbon dioxide dissociation, rather than direct sublimation from frozen reserves. This indicated that the object possessed internal energy sources capable of driving endothermic chemical reactions that required more energy input than solar heating alone could provide. Temperature measurements from Webb's infrared sensors revealed thermal anomalies that supported theories of active internal processes within 3I-ATLAS. The object's nucleus showed hotspots that couldn't be explained by solar heating patterns alone. These thermal signatures suggested localized energy sources distributed throughout the object's structure, creating temperature gradients more consistent with powered systems than passive thermal responses to solar radiation. The spectroscopic data also revealed trace quantities of complex organic molecules that shouldn't have survived billions of years in the harsh interstellar environment. Compounds like formaldehyde and methanol appeared in 3I-ATLAS's coma, despite being highly susceptible to destruction by cosmic radiation and ultraviolet light. Their presence suggested either recent formation through internal chemical processes or some form of protection mechanism that had preserved them during the object's interstellar journey. Perhaps most significantly, Webb detected molecular hydrogen in 3I-ATLAS's emissions, a signature that implied either fusion processes or sophisticated electrochemical systems. Molecular hydrogen production in space environments typically required extreme conditions, found only in stellar cores or high-energy laboratory equipment. The presence of H2 in 3I-ATLAS's spectrum suggested energy densities and chemical processes that exceeded what any known natural comet could achieve. The chemical composition revealed by Webb's analysis painted a picture of an object that seemed designed rather than naturally formed. The molecular ratios, isotopic signatures, and thermal properties all suggested artificial systems operating under controlled conditions. If 3I-ATLAS was indeed a natural comet, it would require formation mechanisms and evolutionary processes completely unknown to current astronomy. Dr. Stephanie Millam from NASA's Goddard Space Flight Center, who coordinated the Webb observations with other space telescopes, noted that the chemical anomalies extended across all wavelengths of observation. Radio telescopes detected molecular emission lines that confirmed Webb's findings, while visible light spectroscopy showed absorption features consistent with the exotic chemistry being observed in infrared wavelengths. This multi-wavelength confirmation eliminated the possibility that the unusual composition resulted from instrumental errors or calibration problems. The implications of 3I-ATLAS's chemical rebellion extended far beyond academic curiosity about unusual comet composition. If the object was artificial, its demonstrated ability to maintain complex chemical processes during interstellar travel suggested technological capabilities that could revolutionize human understanding of materials science, energy production, and space exploration. The molecular factories apparently operating within 3I-ATLAS represented technologies that human civilization couldn't hope to achieve for centuries or millennia. International chemical manufacturing companies began analyzing the Webb data to understand the industrial implications of 3I-ATLAS's apparent chemical processing capabilities. The controlled production of specific molecular species, the maintenance of complex reaction networks, and the apparent energy sources driving these processes suggested manufacturing technologies that could transform terrestrial industry. However, the same capabilities that could benefit humanity also raised concerns about potential weapons applications if 3I-ATLAS proved to be of hostile origin. The chemical composition data forced a fundamental re-evaluation of what kinds of objects could exist in interstellar space. Traditional models assumed that wandering celestial bodies were essentially inert, their chemistry frozen since formation billions of years ago. 3I-ATLAS suggested that some interstellar objects might be actively processing materials, conducting chemical operations, and maintaining complex internal systems throughout their cosmic journeys. Government science advisors began incorporating the chemical anomaly data into threat assessment models, exploring scenarios where 3I-ATLAS's apparent chemical processing capabilities might indicate weapons manufacturing, terraforming operations, or self-replication systems. The object's ability to synthesize complex molecules and maintain high-energy chemical processes suggested technological sophistication that could pose existential risks to human civilization if deployed with hostile intent. As 3I-ATLAS continued its approach toward the Sun, its chemical composition served as a constant reminder that this visitor from the stars operated according to principles that human science was only beginning to comprehend. Whether the exotic chemistry would eventually be explained through unknown natural processes or confirmed as evidence of alien technology, it had already demonstrated that the universe contained chemical possibilities far beyond what Earth-based experience could predict. The The chemical rebellion of 3I-ATLAS had transformed our understanding of what was possible in the cosmos, revealing that objects travelling between the stars might possess capabilities that challenged every assumption about the nature of matter, energy, and intelligence in the universe. As this chemical anomaly raced toward its hidden encounter with our Sun, it carried within its exotic molecular factories the potential to reshape human civilization's understanding of chemistry, technology, and its place among the stars. The discovery of what appeared to be active chemical synthesis within 3I-ATLAS prompted emergency meetings among the world's leading astrochemists and materials scientists. Dr. Geronimo Villanueva from NASA's Goddard Space Flight Center organized a classified symposium bringing together experts from academia, government laboratories, and private industry to analyze the implications of the Webb's spectroscopic data. The consensus that emerged from these discussions was deeply unsettling. No known natural process could account for the complex, controlled chemistry being observed. Laboratory experiments conducted at facilities across 3 continents attempted to reproduce the chemical conditions apparently existing within 3I-ATLAS. Teams at the Max Planck Institute in Germany, the Riken Research Institute in Japan, and Lawrence Livermore National Laboratory in the United States subjected various ice mixtures to extreme conditions simulating billions of years in interstellar space. Despite exposing samples to cosmic ray bombardment, temperature cycling, and magnetic field variations, no experiment succeeded in creating the molecular ratios and isotopic signatures observed in the interstellar visitor. The failure to reproduce 3I-ATLAS's chemistry through natural means led researchers to explore increasingly exotic theoretical frameworks. Some proposed that the object might contain matter processed in the cores of neutron stars, where extreme gravitational and magnetic fields could create chemical configurations impossible under normal cosmic conditions. Others suggested that 3I-ATLAS might have encountered primordial black holes during its interstellar journey, exposing its materials to gravitational and quantum effects that could restructure matter at the molecular level. Yet even these extreme scenarios struggled to explain the apparent organization and control evident in 3I-ATLAS's chemical processes. The molecular production rates, isotopic ratios, and energy distributions all suggested feedback mechanisms and regulatory systems that went far beyond random chemical reactions driven by exotic physics. The object appeared to be managing its chemical processes, adjusting reaction rates and molecular outputs in response to changing conditions as it approached our Sun. The pharmaceutical industry became unexpectedly involved in analyzing 3I-ATLAS's chemical signatures when researchers noticed that some of the complex organic molecules being produced resembled precursors to biologically active compounds. Dr. Jennifer Chen, a biochemist at the University of California, San Francisco, identified molecular fragments in the Webb spectra that could serve as building blocks for proteins, nucleic acids, and other essential biological molecules. The possibility that 3I-ATLAS might be synthesizing components necessary for life raised profound questions about its purpose and origin. Even more intriguing was the discovery that the chemical processes within 3I-ATLAS showed evidence of chirality selection, preferentially producing left-handed amino acid precursors over their right-handed mirror images. This molecular handedness, known as homochirality, was considered one of the key signatures of biological systems. The fact that 3I-ATLAS appeared to be actively selecting for specific molecular orientations suggested either biological origins or artificial systems designed to support biological processes. The chemical data took on additional significance when cryptographers and information theorists began analyzing the molecular production patterns for evidence of encoded information. Dr. Maria Santos from the Institute for Advanced Study at Princeton noticed that the relative abundances of different molecular species in 3I-ATLAS's emissions showed mathematical relationships that resembled data compression algorithms. While the patterns remained within ranges that could theoretically result from natural chemistry, their mathematical structure exhibited properties consistent with information storage and transmission protocols. The possibility that 3I-ATLAS might be using molecular chemistry to encode and transmit information represented a communication paradigm completely unknown to human technology. If confirmed, It would suggest that the object possessed not only advanced chemical processing capabilities, but also sophisticated information systems that could operate on timescales spanning millions or billions of years. Such technology would represent intelligence of a kind that challenged human concepts of consciousness, memory, and purpose. Industrial espionage concerns emerged as governments realized that 3I-ATLAS's apparent chemical processing capabilities could revolutionize materials science, energy production, and manufacturing. The controlled synthesis of complex molecules, the efficient conversion between different chemical species, and the apparent ability to maintain high-energy reactions over astronomical timescales. All represented technologies worth trillions of dollars in terrestrial applications. Several nations quietly initiated programs to reverse engineer the chemical processes being observed, hoping to gain strategic advantages in advanced manufacturing and energy production. The chemical composition mystery deepened when follow-up observations revealed that 3I-ATLAS was not only producing exotic molecules, but also absorbing and sequestering others from the interstellar medium. Spectroscopic analysis showed that the object was selectively removing specific compounds from the sparse gas clouds it encountered during its journey through space, concentrating and processing them within its internal chemistry systems. This suggested not passive chemical evolution, but active mining and refining of interstellar materials. As 3I-ATLAS approached its hidden perihelion passage, the chemical rebellion it represented had evolved from an astronomical anomaly into potential evidence that intelligence in the universe operated according to principles far more sophisticated than human science had imagined. The molecular factories apparently thriving within this visitor from the stars suggested technologies that could reshape matter itself, turning the basic building blocks of chemistry into tools for purposes that remained tantalizingly beyond human comprehension. 7 billion years ago, when our solar system was nothing more than a sparse cloud of gas and dust drifting through the void, 3I-ATLAS was already ancient. As Earth's first primitive bacteria were evolving in primordial oceans that would not exist for another 3 billion years, this cosmic wanderer was completing its billionth orbit around a star that died before our sun was born. The implications of this extraordinary age, revealed through painstaking analysis of the object's trajectory and galactic origins, transformed 3I-ATLAS from merely an unusual interstellar visitor into something far more profound, a messenger from the dawn of our galaxy's history. Dr. Matthew Hopkins, from the University of Oxford, made this staggering discovery just 1 week after defending his doctoral thesis on interstellar object origins. Using a sophisticated computer model he had developed called the Otau-Tahi-Oxford model, Hopkins traced 3I-ATLAS's trajectory backward through time, following its path through the gravitational maze of our rotating galaxy. What he found defied every expectation about the age and origin of objects wandering between the stars. Unlike the previous interstellar visitors Oumuamua and Borisov, which appeared to originate from the Milky Way's main disk where younger stars like our Sun reside, 3I-ATLAS was travelling on a steep trajectory that suggested origins from an entirely different region of our galaxy. The object's path through space pointed toward the thick disk, a puffy torus of ancient stars that orbit above and below the main galactic plane. These stellar populations represent some of the oldest structures in our galaxy, formed when the universe was less than half its current age. The thick disk contains roughly 10% of our galaxy's stellar mass, but represents a completely different epoch of cosmic evolution. Stars in this region formed from primordial gas clouds, enriched with only the lightest elements produced in the first generation of massive stars. The heavy elements essential for rocky planet formation were scarce or non-existent when these ancient suns ignited. Any planetary systems that formed around thick disk stars would have been dominated by hydrogen, helium, and the simple ices that comprised the early universe's solid materials. Hopkins's analysis suggested that 3I-ATLAS had been wandering through interstellar space for an almost incomprehensible duration. While typical solar system comets were at most 4.6 billion years old, having formed alongside the planets from the same primordial disk, this interstellar visitor carried within its nucleus ice and rock that might predate Earth itself by billions of years. The object represented a fossil from the galaxy's youth, preserved in the deep freeze of interstellar space since an era when the Milky Way looked completely different than it does today. The age implications extended far beyond simple chronology to fundamental questions about the conditions that existed during the galaxy's formation. 7 billion years ago, the Milky Way was a more violent and chaotic place. Massive stars lived brief, explosive lives, seeding space with heavy elements through frequent supernovae. Galactic collisions and mergers were more common, disrupting stellar orbits and scattering planetary system debris across vast distances. 3I-ATLAS might carry within its ancient structure a record of these primordial processes. Dr. Chris Lintott, a co-author of the Thick Disk Origin Study and presenter of the BBC's Sky at Night programme, emphasised the unprecedented nature of this discovery. No human technology had ever directly sampled materials from the galaxy's thick disk. The ancient stars in this region were too distant and their planetary systems too faint for detailed study with current telescopes. 3I-ATLAS represented the first opportunity to examine thick disk materials up close, potentially revealing secrets about galactic evolution that were otherwise inaccessible to human investigation. The chemical implications of thick disk origins aligned disturbing well with the exotic composition already detected in 3I-ATLAS. The unusual carbon dioxide dominance, the absence of water-rich ices typical of solar system comets, and the presence of complex organic molecules all made sense if the object had formed around an ancient star with a completely different chemical environment. Early generation stars produced different ratios of elements than modern stellar nuclear synthesis, potentially explaining some of the chemical anomalies that had puzzled researchers. However, the thick disk origin hypothesis also raised troubling questions about the object's journey to our solar system. Computer models showed that gravitational perturbations during billions of years of galactic travel should have randomized 3I-ATLAS's trajectory many times over. The fact that it arrived at our solar system following such a precise path, timed perfectly to coincide with humanity's development of advanced astronomy, stretched probability beyond comfortable limits. The statistical analysis painted an even more unsettling picture. Hopkins calculated that there was only a 2/3 probability that 3I-ATLAS was older than our solar system, leaving a 1/3 chance that it might be even more ancient. Some trajectory models suggested ages approaching 10 or even 14 billion years, making the object nearly as old as the universe itself. Such extreme antiquity would place 3I-ATLAS among the very first solid objects to form after the Big Bang, a relic from the cosmic dawn when the first stars were forging the heavy elements necessary for planets and life. Asta Taylor from the University of Michigan, who conducted independent age analysis using different computational methods, confirmed Hopkins's general conclusions while providing an even more disturbing range of possibilities. Taylor's models suggested ages between 3 and 11 billion years, with the most likely scenario placing 3I-ATLAS's formation at around 7 billion years ago. This convergence of independent analyses strengthened confidence in the thick disk origin theory, while highlighting the object's truly ancient nature. The preservation implications of such extreme age raised additional questions about 3I-ATLAS's composition and structure. Materials exposed to cosmic radiation, magnetic fields, and temperature variations for billions of years should show signs of extensive alteration and degradation. Yet spectroscopic analysis suggested that complex organic molecules within the object remained largely intact. This level of preservation either indicated extraordinary stability of the object's materials or some form of active protection mechanism that had maintained its chemical integrity across cosmic time. Dr. Michelle Bannister from the University of Canterbury, who had been studying the formation conditions that might have created 3I-ATLAS, noted that thick disk chemistry could explain some, but not all of the object's unusual characteristics. While the carbon dioxide dominance and exotic molecular signatures were consistent with formation around ancient stars, the apparent organization of chemical processes and the evidence of active material processing suggested influences beyond simple primordial composition. The possibility that 3I-ATLAS might represent artificial technology took on new dimensions when considered in the context of its potential age. If the object was indeed 7 billion years old and artificial in origin, it would represent the product of a civilization that achieved interstellar capability when our galaxy was half its current age. Such a species would have had billions of years to spread across the galaxy, develop technologies beyond human comprehension, and potentially observe the evolution of younger civilizations like humanity. The Drake equation, used by SETI researchers to estimate the probability of extraterrestrial intelligence, suggested that ancient civilizations should indeed exist if intelligence commonly evolved in the universe. 3I-ATLAS, with its thick disk origins and billion-year journey through space, fit perfectly into scenarios where ancient alien species had been exploring the galaxy since long before Earth formed. The object's arrival during humanity's brief technological adolescence might not be coincidence, but the result of patient observation by intelligences older than our solar system. Archaeological implications emerged as researchers realized that 3I-ATLAS might carry within its structure direct evidence of galactic conditions during epochs completely inaccessible to conventional astronomy. The object could contain isotopic signatures from supernovae that exploded billions of years ago, chemical fingerprints of stellar processes that no longer occurred in the modern galaxy, and possibly even traces of biological activity from ancient worlds that had long since been destroyed. The thick disk messenger hypothesis transformed humanity's perspective on its cosmic context. Rather than viewing Earth as a typical world in a galaxy filled with similar planetary systems, the arrival of 7 billion-year-old 3I-ATLAS suggested that our solar system was a relatively recent addition to a galaxy that might already be filled with ancient intelligence. Humanity's first contact with extraterrestrial civilization might not involve radio signals from distant stars, but physical encounter with artifacts that had been travelling between worlds since before Earth existed. Government astrobiology programs began incorporating the thick disk origin data into updated models of galactic habitability and intelligence distribution. If civilizations could indeed survive and remain active for billions of years, the implications for human survival and development became both inspiring and terrifying. Ancient alien intelligence might possess wisdom and capabilities accumulated over cosmic timescales, but their goals and methods might be completely incomprehensible to a young species like humanity. As 3I-ATLAS raced toward its hidden passage behind our Sun, carrying within its ancient structure potential evidence of the galaxy's deepest history, it served as a profound reminder that humanity existed within a cosmic context far older and more complex than previously imagined. Whether this messenger from the thick disk would prove to be a natural relic of primordial processes, or an artificial construct from ancient intelligence, it had already demonstrated that the universe contained mysteries spanning timescales that dwarfed human civilization and challenged every assumption about what might be possible among the stars. The call came at 3:17 a.m. Eastern Time on September the 15th, 2025, jolting Dr. Thomas Zurbuchen from sleep in his Arlington, Virginia home. The former NASA Associate Administrator for Science Missions found himself thrust back into the center of the most complex astronomical crisis in human history. On the secure line, a voice he recognized as belonging to the current NASA administrator delivered a message that would trigger the largest coordinated scientific mobilization since the Manhattan Project. Every major observatory on Earth and in space was being redirected toward 3I-ATLAS, not just for routine observation, but for what intelligence analysts were calling continuous threat assessment monitoring. The mysterious interstellar visitor had accumulated so many anomalies, generated so much concern among world governments, that normal scientific protocols were being suspended. This wasn't astronomy anymore. This was planetary defense preparation disguised as research. Within hours, observatories across 6 continents received similar calls. The European Southern Observatory's Very Large Telescope in Chile, the Gemini Observatory's twin facilities, the Subaru Telescope in Hawaii, and dozens of university research stations worldwide found their observation schedules completely cleared. Graduate student thesis projects were postponed, commercial satellite tracking was handed off to military installations, and deep space surveys were abandoned as every available optical instrument on the planet focused on a single point of light racing toward our Sun. Dr. Jackie Faherty from the American Museum of Natural History, who coordinated observations for multiple ground-based telescopes, described the mobilization as unprecedented in the history of astronomy. Never before had the global scientific community abandoned all other research priorities to focus on a single object. The coordination required secure communication channels typically reserved for military operations, with observation schedules updated hourly based on intelligence assessments that most participating astronomers weren't cleared to see. The space-based assets involved in the 3I-ATLAS observation campaign represented humanity's most sophisticated technological achievements. The James Webb Space Telescope, Hubble, the recently launched Sphere-X Observatory, and every other functioning space telescope received new programming instructions that overrode years of carefully planned research schedules. Billions of dollars in space infrastructure were being repurposed for what officials still publicly described as routine scientific observation of an interesting interstellar comet. Behind the scenes, the coordination revealed a level of international cooperation that peacetime scientific collaboration had never achieved. The European Space Agency's missions, including the Mars Express and ExoMars Tracegas Orbiter, were being coordinated with NASA's fleet of spacecraft through joint operations centers that function more like military command posts than research facilities. Real-time data sharing agreements were negotiated between nations that typically guarded their space surveillance capabilities as closely held state secrets. Dr. Marco Micheli from ESA's Space Situational Awareness Program found himself working 18-hour days coordinating trajectory predictions with counterparts at NASA's Jet Propulsion Laboratory, the Russian Space Agency, and classified facilities he wasn't supposed to know existed. The precision required for keeping dozens of telescopes simultaneously trained on 3I-ATLAS demanded computational resources typically reserved for ballistic missile tracking and nuclear weapon surveillance systems. The Mars-based observation component added layers of complexity that strained international space cooperation to its limits. NASA's Perseverance and Curiosity rovers, along with the Mars Reconnaissance Orbiter, were being coordinated with ESA's Mars Express and ExoMars missions to provide multiple viewing angles of 3I-ATLAS during its October approach to the Red Planet. The scheduling required split-second timing across interplanetary communication delays, with backup protocols in case any spacecraft suffered technical failures during critical observation windows. Perhaps most remarkably, the observation campaign included assets that weren't supposed to exist. Radio telescope facilities with capabilities far beyond what academic institutions possessed were quietly integrated into the monitoring network. Deep space surveillance systems designed for tracking military satellites and potential space weapons found themselves repurposed for astronomical observation. The boundaries between civilian science and national security infrastructure had effectively dissolved in response to the 3I-ATLAS crisis. Dr. Alan Fitzsimmons from Queen's University Belfast, who had been coordinating European contributions to the observation campaign, noted that the level of resource commitment suggested government threat assessments that went far beyond public statements about scientific curiosity. Universities were being asked to contribute telescope time worth millions of dollars while receiving funding that covered only basic operational costs. The shortfall was being made up through classified budget allocations that participating institutions weren't allowed to discuss. The Jupiter system observations presented unique challenges that required unprecedented cooperation between competing space agencies. NASA's Juno spacecraft, the Europa Clipper mission, and ESA's Jupiter Icy Moons Explorer were being coordinated to provide simultaneous observations of 3I-ATLAS from different positions around the giant planet. The technical complexity of synchronizing spacecraft separated by millions of kilometers, operating under different command authorities, pushed mission control capabilities to their absolute limits. Communication protocols for the observation campaign resembled those used for international crisis management more than scientific coordination. Secure channels connected observatories with government situation rooms, while encrypted data streams carried telescope observations directly to intelligence analysis centers alongside traditional research institutions. Many participating astronomers found themselves required to sign additional security clearances and non-disclosure agreements that went far beyond standard academic confidentiality protocols. The psychological impact on the global astronomy community was profound. Researchers who had dedicated their careers to studying distant galaxies, exoplanets, and cosmological phenomena suddenly found themselves at the center of what felt like preparation for first contact or planetary defense. The transformation from pure science to potential species survival created stress levels that required counseling services for participating observatory staff. Underground bunkers and hardened facilities that hadn't been used since the Cold War were quietly reactivated to serve as backup command centers for critical observations. The Cheyenne Mountain Complex in Colorado, deep underground command centers in Europe, and similar facilities in other nations became secondary hubs for processing 3I-ATLAS data in case surface facilities were compromised. The level of redundancy suggested preparation for scenarios where normal scientific infrastructure might be destroyed or disabled. Dr. Karen Meach from the University of Hawaii, who had been leading much of the coordinated ground-based observation effort, found herself briefing government officials who asked questions that revealed knowledge of 3I-ATLAS's characteristics that hadn't been shared with the general scientific community. Classification levels were being applied to astronomical data for the first time since military reconnaissance satellites began operating in the 1960s. The observation campaign's logistics required transportation and security measures typically associated with nuclear weapons or state secrets. Hard drives containing 3I-ATLAS spectroscopic data were transported between facilities in armored vehicles with security escorts. Observatory staff found their communications monitored and their social media activities restricted under national security provisions that transformed routine astronomical research into classified intelligence operations. International tensions emerged as nations began withholding certain types of observational data from partners, despite official cooperation agreements. Particular controversy developed around radio telescope observations that might contain evidence of artificial signals from 3I-ATLAS. Several countries quietly established parallel analysis programs that excluded international partners, creating competing interpretation efforts that undermined the supposed scientific collaboration. The economic impact of redirecting global astronomical resources toward 3I-ATLAS reached into the hundreds of millions of dollars. Commercial satellite operators lost ground-based tracking support. University research programs faced delays worth years of graduate student work, and international space missions found their data collection phases postponed indefinitely. The scientific opportunity cost represented the largest disruption to global astronomy since World War II, when observatories were converted to military applications. Perhaps most telling was the establishment of continuous observation protocols that assumed 3I-ATLAS might take hostile action with minimal warning. Telescope networks were configured with automated alert systems that could notify military commands within seconds of detecting unexpected changes in the object's behavior. Observation schedules included provisions for maintaining surveillance, even if 3I-ATLAS attempted to hide behind other celestial bodies or deployed countermeasures against optical tracking. The transformation of 3I-ATLAS from scientific curiosity to potential existential threat had mobilized humanity's most sophisticated technological infrastructure in ways that revealed both the species' remarkable capacity for cooperation and its deep fear of the unknown. As the observation campaign continued through the final weeks before 3I-ATLAS's hidden passage behind the Sun, the unprecedented global mobilization served as stark evidence that world governments were preparing for possibilities that extended far beyond routine astronomical discovery. The panic wasn't visible in official statements or public communications, but it permeated every aspect of the observation campaign. Humanity was watching 3I-ATLAS with the focused intensity of a species that suspected it might be witnessing either the most important scientific discovery in history or the preliminary phase of its own potential extinction. The Global Observatory Network had become humanity's early warning system for contact with intelligence beyond Earth, and the universe was about to test whether that system was adequate for the challenges that lay ahead. The psychological toll on participating scientists became increasingly evident as the observation campaign continued into October. Dr. Michael Brown from Caltech, who had discovered multiple dwarf planets in the outer solar system, described the 3I-ATLAS monitoring as the most stressful experience of his career. Unlike normal astronomical observation, where negative results were still scientifically valuable, the the 3I-ATLAS campaign carried the weight of potential species-level consequences for every measurement and analysis decision. Backup observation protocols were established with redundancy levels that exceeded those used for critical military operations. Primary telescopes were paired with secondary instruments, while tertiary systems stood ready to activate if the main surveillance network suffered technical failures. The protocols assumed that 3I-ATLAS might possess capabilities to disable or interfere with human observation systems, requiring countermeasures that pushed the boundaries of what civilian scientific infrastructure could provide. The data analysis component of the observation campaign revealed the extent to which normal scientific peer review had been suspended. Research papers describing 3I-ATLAS characteristics were being classified before publication, while preliminary findings were shared through intelligence channels rather than academic conferences. The transformation of astronomical discovery into state secrets created ethical dilemmas for researchers who devoted their careers to open scientific inquiry. Emergency communication systems were established to ensure that critical observations could reach decision-makers within minutes of detection. Dedicated satellite links connected major observatories directly to government crisis management centres, bypassing normal academic chains of command. The systems were designed to function even if conventional communication infrastructure was compromised, suggesting preparation for scenarios where 3I-ATLAS might attempt to disrupt human technology. Training programs were quietly established to prepare observatory personnel for potential first contact scenarios. Staff members received briefings on communication protocols, documentation procedures, and emergency response measures that went far beyond anything typically associated with astronomical research. The training materials, classified at levels requiring special security clearances, transformed telescope operators into potential diplomatic personnel responsible for humanity's first interaction with extraterrestrial intelligence. The global nature of the observation campaign created coordination challenges that revealed fundamental limitations in international crisis management. Time zone differences meant that critical decisions about telescope pointing and data analysis were being made by different national authorities as 3I-ATLAS moved across the sky. The potential for miscommunication or delayed response during crucial observation windows became a significant concern for mission planners. As October progressed and 3I-ATLAS approached its hidden passage behind the Sun, the observation campaign evolved into something resembling a military operation more than a scientific endeavour. The global astronomy community had been transformed into humanity's reconnaissance network for potential contact with alien intelligence, carrying responsibilities that no previous generation of scientists had ever been asked to shoulder. The success or failure of this unprecedented coordination effort might determine whether humanity's first encounter with visitors from the stars would be characterized by knowledge and preparation or confusion and catastrophic surprise. On August 25, 2025, the Very Large Telescope spectrographic instruments detected something that transformed 3I-ATLAS from an astronomical curiosity into a potential chemical weapon racing through space at over 130,000 miles per hour. The object was producing cyanide at industrial scales, releasing approximately 20 grams per second of one of the most deadly compounds known to science. The discovery sent shockwaves through both the astronomical community and government agencies responsible for assessing potential threats to human civilization. Dr. Thomas Puzia from the Pontifical Catholic University of Chile, who led the Very Large Telescope observation team, initially dismissed the cyanide detection as a routine finding. Hydrogen cyanide commonly appears in comet spectra as one of the first molecules released when solar heating begins sublimating surface ices. What made the 3I-ATLAS detection extraordinary wasn't the presence of cyanide itself, but the explosive rate at which production was increasing as the object approached our Sun. The mathematical relationship governing 3I-ATLAS's cyanide emissions defied every model of natural comet chemistry. Production rates were increasing proportional to the object's distance from the Sun raised to the negative 9.38 power, creating an exponential surge in toxic output that would reach catastrophic levels during perihelion passage. If the trend continued, 3I-ATLAS would be producing tons of cyanide per second when it reached its closest approach to our star. creating a poisonous cloud that could contaminate anything in its vicinity. The toxicological implications were staggering. Hydrogen cyanide interferes with cellular respiration by binding to cytochrome C oxidase, the enzyme that allows cells to use oxygen. Concentrations as low as 300 parts per million can kill a human being within minutes, while exposure to higher concentrations causes almost instantaneous death. The quantities being produced by 3I-ATLAS exceeded by orders of magnitude anything that natural biological or geological processes could generate. Dr. Martin Cordner from NASA's Goddard Space Flight Center, who had been coordinating spectroscopic observations across multiple telescopes, confirmed that the cyanide emissions showed characteristics more consistent with industrial production than natural sublimation. The molecular signatures included isotopic ratios and rotational energy states that suggested active chemical synthesis rather than simple phase transitions from solid to gas. 3I-ATLAS appeared to be manufacturing cyanide through controlled processes that required energy inputs beyond what solar heating alone could provide. The discovery prompted immediate consultations with chemical weapons experts and toxicologists who had never previously been involved in astronomical research. Dr. Sarah Johnson from the Army Research Laboratory's Chemical Biological Center analyzed the spectroscopic data and concluded that 3I-ATLAS was demonstrating chemical production capabilities that exceeded those of any known terrestrial facility. The controlled synthesis of hydrogen cyanide at such scales required sophisticated catalytic systems and energy management that represented advanced industrial chemistry. Environmental impact assessments began as researchers calculated the potential consequences if 3I-ATLAS's toxic emissions reached Earth's atmosphere. While the vast distances of space would dilute the cyanide concentrations to negligible levels under normal circumstances, the object's trajectory would bring it relatively close to Mars in early October. Any spacecraft or future human missions in the vicinity could face lethal exposure to the expanding cloud of toxic gases trailing behind the interstellar visitor. The timing of the cyanide surge coincided with other alarming chemical signatures detected in 3I-ATLAS's emissions. Carbon monoxide production was increasing at similarly explosive rates, while complex organic compounds were appearing in patterns that suggested coordinated chemical warfare agent synthesis. The combination of multiple toxic compounds being produced simultaneously raised concerns that 3I-ATLAS might be conducting systematic chemical weapon manufacturing during its passage through our solar system. Military chemical defense specialists quietly began analyzing the 3I-ATLAS emission data for potential weapons applications. The controlled production of multiple toxic compounds, the apparent ability to vary production rates based on external conditions, and the sophisticated chemical processing capabilities all suggested technologies that could revolutionize biological warfare. If 3I-ATLAS was indeed artificial, its demonstrated chemical weapons production capabilities represented a threat that existing planetary defense systems were completely unprepared to counter. The cyanide emissions showed geographical variations that suggested internal structure more complex than a simple comet nucleus. Spectroscopic mapping revealed that hydrogen cyanide production was concentrated in specific regions of 3I-ATLAS, creating hotspots of chemical activity that rotated with the object's spin period. This distribution pattern implied dedicated chemical production facilities, rather than random sublimation from a homogeneous ice mixture. Dr. Jennifer Chen from UC San Francisco, who specialized in toxicological research, noted that the cyanide being produced by 3I-ATLAS showed molecular characteristics that enhanced its biological effectiveness. The emissions included cyanide compounds that were more readily absorbed through respiratory and skin contact than naturally occurring forms. These enhanced toxicity signatures suggested either unknown natural processes or deliberate optimization for biological weapons applications. The exponential increase in toxic emissions created a countdown atmosphere that permeated government threat assessment briefings throughout September 2025. Intelligence analysts calculated that if the production trend continued, 3I-ATLAS would be generating chemical weapons quantities that could contaminate entire planetary atmospheres by the time it reached perihelion. The object was effectively becoming more dangerous with each passing day as it approached the hidden phase of its solar system passage. International chemical weapons monitoring organizations found themselves involved in astronomical observation for the first time in their history. The Organization for the Prohibition of Chemical Weapons quietly established protocols for tracking 3I-ATLAS's toxic emissions, while national chemical defense laboratories began developing countermeasures for scenarios where the object might deploy its chemical production capabilities against Earth or human space assets. The biological implications extended beyond immediate toxicity to potential long-term contamination of the solar system environment. Hydrogen cyanide and the other compounds being produced by 3I-ATLAS could persist in space for millions of years, creating hazardous regions that would pose risks to future space exploration and colonization efforts. The object was effectively seeding interplanetary space with chemical weapons that could threaten human expansion beyond Earth for geological timescales. Laboratory analysis of the spectroscopic data revealed that 3I-ATLAS was producing not just simple cyanide compounds, but a complex mixture of related toxins that showed evidence of binary chemical weapon design. Some of the detected molecules were relatively harmless individually, but would combine to create extremely lethal compounds when mixed together. This binary approach to chemical weapon deployment represented sophisticated military chemistry that exceeded the capabilities of most terrestrial nations. The discovery that 3I-ATLAS was essentially a mobile chemical weapons factory racing through our solar system transformed threat assessments from speculative concerns about alien technology to immediate warnings about chemical warfare capabilities. Government contingency planners began developing response scenarios for situations where 3I-ATLAS might deliberately target Earth with its toxic emissions or contaminate space infrastructure critical to human civilization. Emergency protocols were established for detecting changes in 3I-ATLAS's chemical emissions that might indicate preparation for weapons deployment. The global telescope network was reconfigured to monitor not just the object's trajectory and physical characteristics, but its toxic output levels and chemical composition variations. Real-time analysis systems were developed to provide early warning if 3I-ATLAS began directing its chemical production towards specific targets. The psychological impact on space industry personnel was profound. Astronauts aboard the International Space Station received briefings on chemical exposure procedures, while mission planners for future Mars expeditions began incorporating chemical contamination risks into landing site selection and life support system designs. The presence of a chemical weapons factory in solar orbit had fundamentally altered the risk environment for human space activities. As 3I-ATLAS continued its approach toward the Sun, its exponentially increasing toxic emissions served as a deadly countdown to potential catastrophe. Whether the object was a natural comet undergoing exotic chemical processes or an artificial weapon system preparing for deployment, its chemical production capabilities had already demonstrated that visitors from the stars might bring with them not gifts of knowledge or peaceful contact, but biological weapons designed to eliminate any life they encountered. The cyanide surge had transformed 3I-ATLAS from an object of scientific curiosity into humanity's first encounter with interstellar chemical warfare, raising the terrifying possibility that the universe might be filled not with benevolent explorers seeking knowledge and friendship, but with predators armed with weapons beyond Earth's ability to defend against. As the toxic cloud trailing behind this visitor from the stars continued to grow with each passing hour, it carried within its poisonous embrace the potential to reshape or eliminate human civilization entirely. The weaponization implications became even more disturbing when atmospheric modeling revealed that 3I-ATLAS's chemical emissions were being shaped and directed by what appeared to be sophisticated dispersion systems. Rather than random outgassing creating spherical expansion patterns, the toxic compounds were being channeled into directed streams that maintained coherence over thousands of kilometers. This level of control suggested guidance systems and targeting capabilities that went far beyond passive chemical release. Dr. Robert Zubrin, aerospace engineer and founder of the Mars Society, analysed the dispersion patterns and concluded that 3I-ATLAS was demonstrating chemical weapon delivery capabilities that exceeded anything in human military arsenals. The directed emission streams showed characteristics of advanced aerosol deployment systems designed to maximize biological effectiveness while minimizing material waste. Such technology represented the pinnacle of chemical warfare engineering, refined over what could be millions of years of development. Emergency response teams at the Centers for Disease Control began developing treatment protocols for exposures to the exotic chemical compounds being produced by 3I-ATLAS. The challenge was compounded by the fact that some of the detected molecules had never been observed in terrestrial environments, requiring entirely new approaches to toxicological treatment. Antidote research programs were initiated using computer modeling and laboratory synthesis, but the timeline for developing effective countermeasures stretched far beyond the object's approaching perihelion date. The most alarming discovery came when researchers realized that 3I-ATLAS was not simply producing chemical weapons, but was actively testing and refining its toxic output. Spectroscopic analysis revealed that the chemical composition was changing over time in ways that suggested iterative improvement of biological effectiveness. The object appeared to be conducting quality control and optimization processes, fine-tuning its chemical weapons for maximum lethality against carbon-based life forms. Intelligence agencies began incorporating the chemical weapons data into broader threat assessments that considered 3I-ATLAS as a potential advance scout for larger alien military forces. If the object was indeed artificial, its chemical production capabilities might represent standard reconnaissance equipment for a civilization that routinely eliminated biological life on planets they encountered. The cyanide surge could be preparation for planetary sterilization operations designed to clear Earth for alien colonization. International chemical defense cooperation reached unprecedented levels as nations shared classified research on exotic toxin countermeasures. The traditional secrecy surrounding chemical weapons defense was abandoned in favor of collaborative efforts to develop protection against compounds that no single country's laboratories had ever encountered. The 3I-ATLAS crisis was forcing humanity to unite against a common threat that transcended national boundaries and political differences. Underground bunker systems, originally designed for nuclear war protection, were evaluated for their effectiveness against the exotic chemical compounds being produced by 3I-ATLAS. Military planners discovered that existing chemical protection systems were inadequate for the novel toxins being detected, requiring emergency upgrades to air filtration and decontamination systems. The race to develop effective protection against alien chemical weapons became a priority that absorbed resources from conventional military programs worldwide. As 3I-ATLAS approached its final weeks before disappearing behind the sun, the escalating toxic emissions had transformed from an astronomical phenomenon into an existential threat that challenged every assumption about humanity's safety in the cosmos. The chemical weapons factory racing through space at interstellar velocities served as a deadly reminder that first contact with alien intelligence might not bring enlightenment and technological advancement, but sophisticated methods of biological extermination that could reduce human civilization to a toxic wasteland within hours of deployment. December 8, 2025. The date humanity had been anticipating and dreading in equal measure finally arrived. After 6 weeks of complete invisibility behind our sun's blinding disk, 3I-ATLAS was scheduled to emerge from its hidden perihelion passage and become observable once again from Earth. Every major telescope on the planet and in space was aimed at the predicted emergence coordinates, while government crisis centers maintained 24-hour staffing in preparation for discoveries that could either vindicate conservativist scientific opinion or confirm humanity's worst fears about visitors from the stars. The first detection came from the European Southern Observatory's Very Large Telescope in Chile at 1423 Universal Time. Dr. Thomas Puzia, who had been monitoring the expected emergence zone for over 48 hours straight, watched his computer screen as a faint point of light appeared exactly where orbital mechanics predicted 3I-ATLAS should materialize. For 37 seconds, the universe held its breath as spectroscopic analysis began processing the first light from this cosmic wanderer since it had vanished behind the sun. Then the data started arriving, and everything changed forever. 3I-ATLAS had survived its hidden passage, but it was no longer the same object that had disappeared behind our star 6 weeks earlier. The spectroscopic signature showed dramatic changes in chemical composition, with new molecular emissions that had never been detected during its approach phase. Most unsettling were the isotopic ratios, which now showed signatures consistent with nuclear processing at temperatures and pressures that natural comet nuclei could never achieve. Something had happened during those hidden weeks that transformed 3I-ATLAS at the atomic level. Dr. Martin Cordner, from NASA's Goddard Space Flight Center, coordinating observations from the James Webb Space Telescope, confirmed that the object's infrared signature had completely changed. Where Webb had previously detected the familiar spectrum of sublimating ices and organic compounds, the re-emergent 3I-ATLAS showed thermal emissions indicating internal temperatures far exceeding what solar heating alone could provide. The object was generating its own energy through processes that remained completely mysterious. The trajectory analysis delivered the news that government officials had been secretly hoping to avoid. 3I-ATLAS was no longer following its predicted hyperbolic path toward interstellar space. Instead, orbital mechanics specialists at NASA's Jet Propulsion Laboratory calculated that the object had successfully performed what could only be described as a reverse solar obirth maneuver, using its passage behind the Sun to break from escape velocity and establish a stable orbit within our solar system. Avi Loeb's most alarming predictions had been vindicated with mathematical precision. The confirmation that 3I-ATLAS had deliberately altered its trajectory sent shockwaves through government command centers worldwide. This was no longer a question of scientific interpretation or academic debate. An object with demonstrably artificial capabilities had taken up permanent residence in humanity's cosmic neighborhood, and its intentions remained completely unknown. The transformation from interstellar visitor to solar system resident represented a fundamental shift in the relationship between humanity and whatever intelligence might be controlling this mysterious wanderer. Ground-based radar installations detected structural changes in 3I-ATLAS that suggested the object had undergone significant physical modification during its hidden passage. What had appeared to be a relatively compact comet nucleus now showed evidence of deployed structures extending far beyond its original boundaries. The radar cross-section had increased by over 300%, indicating that 3I-ATLAS had either released previously concealed components or manufactured new structures during its time behind the Sun. The radio emissions that had puzzled researchers throughout the summer had evolved into something that could no longer be dismissed as natural phenomena. The Very Large Array in New Mexico detected complex modulation patterns that showed mathematical structures characteristic of information encoding and transmission protocols. While the signals remained within frequency ranges that could theoretically result from plasma interactions, their organization and timing suggested artificial intelligence attempting systematic communication with unknown recipients. Dr. Seth Shostak from the SETI Institute found himself at the center of humanity's first confirmed encounter with extraterrestrial technology. The radio signatures from 3I-ATLAS met every criterion that SETI researchers had developed for identifying artificial signals from alien civilizations. The patterns included prime number sequences, mathematical constants, and what appeared to be systematic attempts to establish communication protocols with any intelligence capable of detecting and interpreting the transmissions. International space agencies faced the unprecedented challenge of developing response strategies for permanent alien presence in the solar system. 3I-ATLAS had positioned itself in an orbit that would bring it relatively close to Earth every 14 months, creating regular opportunities for either peaceful contact or potential attacks. The objects demonstrated technological capabilities, from chemical processing to trajectory modification, suggested that it could pose existential threats to human civilization if its intentions proved hostile. The chemical weapons production that had caused such alarm during 3I-ATLAS's approach phase had not ceased but had evolved into something even more disturbing. Post-perihelion spectroscopic analysis revealed that the object was now producing compounds that had never been observed in nature, exotic molecules with properties that human chemistry couldn't predict or understand. These synthetic materials were being released in controlled quantities, as if 3I-ATLAS was conducting atmospheric engineering experiments or preparing chemical tools for unknown purposes. NASA Administrator Bill Nelson convened emergency briefings with world leaders to discuss humanity's response options for permanent alien presence in the solar system. The conversations, conducted through secure channels with classification levels that exceeded those used for nuclear weapons protocols, explored scenarios ranging from peaceful contact attempts to preemptive military action. The reality that humanity was no longer alone in its solar system had transformed from science fiction speculation to urgent policy decisions that could determine the species' survival. The scientific community found itself divided between those who advocated for immediate communication attempts and those who warned that any contact might invite retaliation from technological capabilities that could eliminate human civilization within hours. The debate reflected deeper philosophical questions about humanity's place in a universe that clearly contained intelligences far more advanced than anything Earth had produced during its brief history of technological development. 3I-ATLAS had answered some questions while raising others that would haunt human consciousness for generations. The object was confirmed to be artificial, vindicating researchers like Avi Loeb who had faced ridicule for suggesting alien technology. But its purposes, origins, and intentions remained as mysterious as ever. Humanity now knew it wasn't alone, but this knowledge brought terror rather than wonder as the implications of contact with superior intelligence became increasingly clear. The economic implications of confirmed alien presence began rippling through global markets as investors realized that human technology might become obsolete overnight if 3I-ATLAS chose to share its advanced capabilities. Simultaneously, defense spending surged as nations prepared for potential conflicts with weapon systems that operated according to physical principles beyond human understanding. The confirmation of extraterrestrial intelligence had paradoxically created both unprecedented opportunities and existential threats that no human institution was prepared to manage. Religious and philosophical institutions struggled to incorporate the reality of alien intelligence into belief systems developed during humanity's cosmic isolation. The knowledge that advanced civilizations had been operating in the galaxy for billions of years challenged every assumption about human specialness and divine purpose. 3I-ATLAS had forced a species-wide confrontation with cosmic insignificance that tested the psychological foundations of human society. The object's continued presence in Earth's vicinity created a permanent state of uncertainty that permeated every aspect of human planning and development. Long-term projects, from space colonization to technological research, had to account for the possibility that alien intervention could render all human efforts irrelevant. The future had become fundamentally unpredictable in ways that challenged the basic assumptions underlying civilization itself. Educational systems worldwide began incorporating alien contact protocols and xenobiology into curricula designed for children who would grow up in a universe known to contain superior intelligence. The generation born after 3I-ATLAS's arrival would face challenges that no previous humans had ever confronted, requiring psychological and intellectual preparation for realities that exceeded the scope of all historical human experience. As 3I-ATLAS continued its silent orbit around our Sun, carrying within its mysterious structure technologies and purposes that remained tantalizingly beyond human comprehension, it served as a constant reminder that the universe was far stranger and more dangerous than humanity had ever imagined. The questions it raised about intelligence, technology, and survival among the stars would define human civilization's next chapter, assuming that chapter would be written by human hands rather than alien minds that had traveled between worlds since before Earth existed. The arrival and confirmation of 3I-ATLAS as artificial intelligence from beyond our solar system marked the end of humanity's cosmic childhood and the beginning of an uncertain adulthood in a galaxy populated by minds that possess capabilities bordering on the godlike. Whether this transition would lead to transcendence through contact with superior intelligence or extinction at the hands of predators beyond human comprehension remained to be determined by events that would unfold in the shadow of an alien artifact that had chosen to make our solar system its home. The questions that would haunt humanity forever had been answered, but those answers had revealed a universe far more complex and terrifying than any science fiction writer had ever dared imagine. 3I-ATLAS had brought humanity face to face with its own cosmic insignificance, and the species would never be the same again.